Hello, this is the fifth video in the P3 flipped learning sequence from Darton College's Science Department on forces and motion. Right, the aim of this video, and after watching it, we should be able to describe the ways that different forces can affect the motion of an object. We should be able to work out something called resultant force, and we should be able to use this equation here, which is force is equal to mass times acceleration, and rearrange that to work out mass or acceleration, whichever thing you need to do. So basically three key things. If you apply a force to an object, it can do one of three things. It can either change its speed, change its shape, or change the direction of the object. Here in the picture we have the direction and the speed being changed in this rocket. Probably its shape slightly as well because of the extreme forces that it's under. In order to know the effect on an object, you need to know a little bit more about what it's already doing. So if an object is already moving in a certain direction, then applying a force in the same direction will lead to acceleration. If you apply force in the opposite direction, then it will lead to deceleration. We must, in order to predict the effect on motion, you must also know what direction movement is already occurring in. So in these questions here, I'm going to assume that the cars are both travelling in that direction. So in the first situation, what we have here is a larger force acting in forward direction than in reverse. This is probably friction or something like that, and this is the force from the engine. So what we'll have is acceleration of this car because it is travelling in that direction already. In the second one, it's even more important that we know what the car's already doing, because what you have here is a situation where the forward and the reverse force are completely balanced. Now it's natural to think that this would lead to no movement at all, but that's not the case. What you get is the movement staying the same. So if the object is stationary, it will stay stationary. If it's moving at 30 miles an hour, it will stay moving at 30 miles an hour. That's why knowledge of movement already is vital when working out what's going on in force diagrams. Now we have resultant force. Resultant force is effectively the combined effect of all the forces involved. So in this situation you've got 2 newtons and 3 newtons both going forward, so the resultant force is 5 newtons in that direction. In this situation you've got 1 newton going forward and 2 newtons going forward, so resultant force is 3 newtons. And in this situation you have 1 newton going backwards and 3 newtons going forward, so the resultant force will be 2 newtons in a forwards motion. It's just about taking into consideration all the forces that are involved. So if you apply the same force to 3 different objects, what you end up with is greater acceleration when you're using a lighter object than when you're moving a heavier object. That makes perfect sense to me, and it leads to this very straightforward equation that we end up with, which is that the force is equal to the mass of an object multiplied by the acceleration. Don't forget, force is measured in newtons, mass in kilograms, and acceleration in meters per second squared. So here's that equation again. In a triangle form, you know how to use triangles. You're covering up the one that you want to find out. So if you want to find out force, cover that up, and that leads to mass times acceleration. You might want to try these questions before I go through them. First one, you've got a force. You're asking you to work out acceleration, so it's force divided by mass. It's 1,000 divided by 500, which gives you acceleration of 2 meters per second squared. The second question, you have a force of 3,000 newtons. It's asking you to work out the mass of the car, and acceleration is 1.5 meters per second squared, so it's 3,000 divided by 1.5. So in this situation the mass of the car is 2,000 kilograms. In the third question it's asking you to work out force, so the mass of the car is 500, acceleration is 5, that gives you a force 2,500. And in the fourth question you have a force of 10 newtons applied by a boy lifting a mass of 20 kilograms, so it's 10 divided by 20, giving you acceleration of 0.5 meters per second squared. Here's another applied situation. It's asking you to work out acceleration. What we have here is a resultant force diagram. So first thing to do is to work out the resultant force, which is 400 newtons. The engine of the car is providing a thrust, blah, 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 blah. Mass is 800. What's the acceleration? So if force is 400 divided by the mass of 800, acceleration is 0.5 meters per second squared. So in summary, forces can alter the speed, shape or direction of an object. Resultant force is essentially the overall force. You have to take into consideration all the forces acting on an object. The greater the force, the more it will accelerate. And objects with more mass take more force to slow them down or to decelerate more slowly. And the inverse is also true, so they take more mass to accelerate them. That concludes this video. Please don't forget to bring your evidence to your lesson in your purple books. Thank you for watching. Goodbye.